Morning.
Good morning. Good morning, sir. Good morning. Good morning, everyone. Hope all is well. Hope everything's going all right. Looks like everybody is in, so we're good. All right, so let's see where we left off.
Hey, Mr. Tucker.
Yes, sir.
How you doing this morning?
I'm good, man. How about yourself?
I'm doing good. Thanks for asking. Hey, man, I got quit on Thursday at 9. I just show up here a little later or what? So,
No, okay. So you broke up a little bit. What'd you say happened?
I got quit on Thursday at 9 o'clock.
Oh, okay.
So
Okay.
I was just, I can turn my computer on or something.
Yeah, I mean, well, it's up to you what you can what you're allowed to do. I mean,
Video.
yeah, it's all good, man. You don't have to push it.
Okay.
If you can't log on at that time, then I'll send the lecture out.
Okay.
So I won't count it against you if you can't make it. It's all good.
All right. Thank you.
Yeah, no problem. Let me see. We did factoring was the last thing. So we're looking at 14 today. All right, rational functions. So everybody, any other questions, concerns, comments before we get rolling? Make sure we're all right. All right, so let me write this a little better. So we're looking at 14.1 today, simplifying rational expressions. All right, so rational expression is just another name for a fraction. For the most part, we're going to have variables in our denominators now. So that's what's making it a rational expression. But just another way of expressing another term used for fractions. So we have these are examples. 5 over x plus 7 is a rational expression. X plus 3 over x minus 5. X squared plus 3x plus 9 over x squared plus 5x plus 6 and 10 over x. All of those are just examples of rational expressions. All right, so this is anything unless it come up, so I'll just leave it right there. But that doesn't do anything to do with the problem. Somebody asked me about that. So here they give us the function mx, m of x is equal to x plus 3 over x minus 5. Determine the function values if possible. I'll note this up here. All right, so they give you m of x is equal to x plus 3 over x minus 5. Then they ask you to find m of 2. All right, so that just means we're going to take 2 and plug it in where we see x. And that's 2 plus 3, 2 minus 5. 2 plus 3 is 5 in the numerator. 2 minus 5 is -3. And so that's what I was talking about up here then. That 3 in the denominator, normally that's not left in the denominator. You can either bring it up top like you did here or put it up front like I did down here. Either way, all three of these things represent the same value. It's just that leaving -3 in your denominator, leaving it negative in your denominator is not proper notation. Either you bring it up to your numerator or you place it in front of the fraction altogether. So that's what, this is talking about. But our answer should be -5/3. All right. Any problems? Then they ask us to find m of 5. So that means plug in 5 where x was. So it's 5 + 3 over 5 - 5. So that'll be 8/0, which is undefined because you cannot have 0 in your denominator. So if ever you get 0 in your denominator, that is undefined. No matter what you're doing, 0 in your denominator is undefined. Notice in the red circle, if I had 0 in the numerator, that's fine because that's just 0. You can divide into 0, you just cannot divide by 0. All right. Scroll up, everyone okay? So the next one is another type of example. They give us P of V. So our expression is P of V is equal to V plus 5 over V plus 7. And they ask us to write the domain in set builder notation. So in order to find the domain, we got to ask ourselves what cannot be used for V. In other words, what can I not plug in for V? All right, so in order to figure that out, we'll set the denominator equal to 0. Because remember, when our denominator is 0, we just saw that our fraction will be undefined. So we're going to set the denominator equal to 0 and then solve. So V plus 7 is equal to 0, minus 7 from both sides. And we have V equal to -7. And that is the value that cannot be used because when V is -7, if you were to plug it back in here, you put a -7 in your denominator, -7 plus 7 give you 0 in your denominator. We cannot use that value. So if I want to write it in set builder notation, that's what it asks for. You got V, then use the line, then describe what you're talking about. V is all real numbers, and V cannot be equal to -7. So you can use everything else, you just cannot use -7. So that's what that's saying. Any problems? Any problems? All right, next one, write the domain in interval notation. So we talked about interval notation before. And so remember, you can only use, you can use everything except for 7, -7. I'm gonna write this in red since I used that red. So just make sure you give an account for all of your intervals. That's what we have right here, just a generic number line. So it shows that we come from -infinity to -7, and -7 to positive infinity. Don't forget to use your union symbol. What else? Also, we use a parentheses on the -7 because we cannot use -7. And new problems. All right, scrolling up. Same directions. A plus 8 is over a squared plus 5a minus 3. So we need to look at what the restrictions are. Restrictions are on A. That's what -7 was last problem, the restriction on what V could be. This time we're looking at what the restrictions on what A can be. So we set our denominator equal to 0. All right, so a squared plus 5a minus 36 is equal to 0. I factor that to a plus 9a minus 4. And set them both equal to 0. It's a plus 9 equal to 0, which gives us -9 once you solve. A minus 4 equal to 0. That gives you a positive 4 once you solve it. So the restrictions are -9 and 4. That means I can use everything else. I just cannot use those two values. When I plug in either one of those numbers, I'll get 0 in my denominator. Problems, any problems? So the first one, set builder notation. So we have this time instead of V, we have A. So we have A slash A is all real numbers, and A cannot be equal to -4 or -9 or 4. So that's how you write your set builder notation. All right. So we look at the number line here. I'm gonna try to color code this thing like I did the last one. So notice how we have our intervals broken up, went from -infinity to -9, -9 to 4, and then 4 to infinity. So that just shows us in interval notation that we can use any value we want except for -9, 4. Anything less than -9, anything between -9 and 4, anything greater than 4. So Any questions? Any questions? All right. So they want you to simplify rational expressions. What they would do is they will give you a rational expression, and your goal should be to factor as much as possible from in numerator and denominator, and then cancel out what you have in common. All right. So factor out that numerator. I got x plus 5, x plus 9. And do it. Factor out denominators, x plus 9, x minus 7. And then you cancel out those x plus 9 quantities, and that leaves us with just x plus 5 over x minus 7. All right, questions. So next time they give us just this, 3p minus 15, 3p squared minus 75. And once again, you want to factor completely. So the first thing I did in both cases was I factored out 3. So it gets 3 times p minus 5, 3 times p squared minus 25. So in the denominator, I have a difference of squares. So that breaks down to 5 plus 3, 5 minus 3. And now cancel out what is in common with each. Numerator and denominator is 3's. Then there's p minus 5. Don't forget, when everything cancels, everything in the numerator cancels, so it leaves me with 1. So that'd be 1 over p plus 5. Any questions? Any questions? All right. Let's do another one. So we have p plus 1 times p minus 2 cubed. And then p plus 1 squared in denominator times p minus 2. So all I did was just expand everything out. So we look at, so if I look at my numerator, there's 1p plus 1 and 3 p minus 2's. In the denominator, there's two p plus ones and one p minus two. So you cancel out what they have in common. Remember, you'll cancel out things once. So if I only have one p plus one, then I'll cancel out one p plus one. In here, I have a p minus two and a p minus two. So it leaves me with two p minus twos up top, right here. And then there's one p minus or p plus one down bottom. So that's my answer. Problems. Look at the next one. So they give us 8y plus 8 over 2y squared minus 6y minus 8. Also, just point out, notice how this, depends on your ability to factor. So make sure your factoring skills are straight, so you'll be able to execute the problems. Factored out 8 from the first, from the numerator. Factored out 2 from the denominator. 8 times y plus 1. And then 2 times y squared minus 3y minus 4. Now that y squared minus 3y minus 4 can be factored into y plus 1, y minus 4. Then you cancel out what's in common. Y plus 1s will cancel. Then there's also 2 that's in the 8 that will cancel out with the 2 that's in the denominator, leaving you with just 4. So the result is 4 over y minus 4. No questions. No questions. All right, so that's it for 10-1, not 10-1, 14-1. Let's look at 14-2, and then we'll call it a day. So we're going to multiply and divide rational expressions. So let's make sure we're cool with the process. We have 2 times 3 times 9 minus 4. We'll multiply 2 fractions. One thing that I can do is break them down. So you want to say factor it down, right? At least in our prime factorization. So when we look at 9, because 2 and 3 can't be broken down in, so they just stay the way you're saying, stay the way they are. If I look at 9, it breaks up into 3 times 3. If I look at 4, it breaks up into 2 times 2. That's all I did was I broke both of these down. So what that enables us to do is to cancel out the things that are in common with the top and the bottom. Sorry about that. And so 3's cancel. And then 1 set of 2 will cancel. And that leaves you with just 3 over 2, which would be your fraction. Fraction is the most simplified form. All right. Let's look at another one. do some of the stuff. So we have 5r squared, s to the fourth. This is the original problem. Over 28r s cubed plus 14r squared over 20s squared. All right, so we're going to look at canceling out things that are in common with the top and bottom. I broke down my 14 into 2 times 7, my 20. That's 2 times 2 times 5 times 5, and then 28, 2 times 2 times 7. Sorry, I think I said 20, I had too many fives. 20 is 2 times 2 times 5. Oh, it's all good. It's all good. Thanks for letting me know. So before we go canceling, everybody okay with what we broke it down, how we broke it down? All I did was broke down the numbers 28, 14, and 20. So now we can cancel out what's in common with the top and bottom and try to be color coded in what I did. So notice there's a 2 with the red slash, I canceled out 2. With the green slash, I canceled out 5. Purple was me canceling out the 7s. And that is all that's in common with the top and bottom. From there, I multiplied what was in common as far as the top was concerned. So you see the red square, I mean r squared times r squared. That's both of those are at the top. So that's how I got. That's how I got r to the fourth, r squared times r squared. That was left. And then of course, s to the fourth is there as well. And then down bottom, I have s cubed times s to the second. That's how I got s to the fifth. And then 2 times 2 times 2 is 8. Like I said, just trying to color code what I did. So that leaves me with s to the fourth, r to the fourth, s to the fourth over 8, r s to the fifth. We still can simplify because r to the fourth over r. Subtract your exponents, and s to the fourth over s to the fifth. Subtract your exponents. That's r cubed times r to the negative first power. 1/8 is still out front. So simplify as much as possible. That's r cubed in the numerator. Bring the s down to your denominator to write it as in power, a positive exponent. Oh, excuse me. All right, questions before we go to the next one. All right, scroll up. So here we have 3w plus 21 over 16w to the 6 times 64w to the 6 over 9w plus 63. So I factored out 3 from the first numerator, 3 times w plus 7. Now I have w 16 by 16w to the 6 in that first denominator. So I decided to write this 64 as 4 times 16. So I can cancel out that whole 16 that's in the denominator. Then I factored out 9 from the last one, giving me w plus 7. So then we go cancel out. All right, so we see threes can cancel with one of the threes that are in the 9. That leaves you with a 3 still left up because 9 is 3 times 3. So one of those threes can cancel. W plus 7 will cancel. 16w to the 6 will cancel. Hey, what there's left? There's a 4 in the numerator and a 3 in the denominator. Excuse me. All right, any problems? So we have 7y squared plus 21y plus 14 over 35y plus 35 times y minus 2 over y squared minus 4. So once again, we factor what we can. First one, we factored out 7. That leaves me y squared plus 3y plus 2 inside of parentheses. First denominator, factor out 35. That leaves y plus 1. And then when you look at y squared minus 4, y plus 1, y plus 2, y minus 2 would be the difference of squares. That would be the factorization of that. Any problems so far? All right. Factored out y squared plus 3y plus 2. That give me y2, y plus 2, y minus 1. Y plus 2, y plus 1. Then I started canceling out. 7 and 7 cancels from that 35. Y plus 2 cancels, y plus 1 cancels, y minus 2 cancels. So what you're left with is just 1 over 5. Any problems with multiplication? We'll look at division. All right, division, 2/3 divided by 9/4. Don't forget, whenever you divide by a fraction, you have to multiply by the reciprocal. So that's 2/3 times 4/9. Well, let me say it's 2/3 divided by 9/4 turns into 2/3 times 4/9. Change the multiplication, then multiply by the reciprocal. Two-thirds times 4/9, multiply across, that'd be 8/27. All right, so let's look at applying that to our rational expressions. So we have S over S minus 7 divided by S cubed plus 6S squared plus 7S over S squared minus 49. So what I would do is go ahead and change the multiplication to flip that following fraction before I go factoring anything. Just change the division to multiplication and flip the following fraction. So it means now we have S squared minus 49 over S cubed plus 6X squared minus 7S. Factor each. So S squared minus 49 is X plus 7, S plus 7, X minus 7. Fraction denominator under it. If you factor out S first, we'll give you S squared plus 6S minus 7. And then factor that out. So we have S over S minus 7 times S plus 7, S minus 1 over S times S plus 7, S minus 1. S plus 7, S minus 7 over S times S plus 7, S minus 1. Hold on 1 second. Let me make sure if there's anything I need to attend to. All right, sorry about that. So now we're looking to cancel out some stuff. So if we cancel out S, we cancel out S plus 7, cancel out S minus 7, and what you're left with is just 1 over S minus 1. All right, any problems before we do another one? All right, next one, 6m squared minus 54m divided by m squared minus 9m over m squared minus 10m plus 10, I mean plus 9, excuse me. So once again, flip that following fraction, change division to multiplication. Go ahead and factor. So if we factor out, that'll be 6m times m minus 9. Then the next numerator will be m minus 1, m minus 9. Then that second denominator, m times m minus 9. Then cancel out. We have an m that's in common, m minus 9 that's in common. So it leaves us with 6 times m minus 1 times m minus 9. Any problems? All right, next one, 5y minus y squared over y cubed minus 125 divided by y over y squared plus 5y plus 25. All right, flip the fraction, change the multiplication. So we did right here. Haven't factored anything, we just follow the division process. Means you change the multiplication and flip the fraction that follows it. Now y cubed, now it's time for us to go to factoring. Let's see if I really think of it. And we know we can factor out y from that numerator, leaving you 5y times 5 minus y. In that denominator, notice there's a difference of cubes. So I factor that out. And that's what's going on right here. So the red is the difference of cubes formula. And we have y cubed minus 5 cubed. So you can plug that in according to the distance of cube formula relationship. So if you have y cubed minus 5 cubed, let y be, plug in y for x, plug in 5 for y. And so that's what we did right here. Mimicking this pattern of x and y. So that'll be y minus 5 times y squared plus 5y plus 25. All right, so now when we look to cancel, we have y that will cancel. And then notice y squared minus 5y plus 25 will also cancel. The whole trinomial will cancel. And so that will leave us with 5 minus y over y minus 5. Everybody good up to this point? Make sure we're okay. All right. So notice we have now 5 minus y over y minus 5. I decided to rearrange my terms in numerator so we can make a clean comparison. So we're just comparing y to y, 5 to 5. If you notice when I do that, that y is still negative. So I brought that out front and let the y stay positive, and I put that in the back. So now I'm comparing, I have a negative y over positive 5 and then a positive and a negative. So you see that each one of our signs are different. Each one of the signs are different. So what I could do is factor out -1. That's what's happening here. When I do that, I'll be left with y minus 5. When the y minus 5 is canceled, it'll leave you with just -1. So the short way of doing that is just recognizing that if you look at what you have, if each sign is different, then your result will be -1. It will. If the only thing that's different between the two is that each sign is different, then that will cancel out and give you -1.
So tuck up.
Yep.
Well, this is a difficult class here today.
I feel you, sir, but we had to go through it. There was nothing I could do about it.
Ain't lying, man, boy.
So yeah, just take it one step at a time. And then whatever question you guys come across, anything y'all need me to review or to do over, just make sure you bring them to class and we can knock them out. It's not a big deal. So, when you guys get to this point in the homework, if you need to redo it, just bring the question to class and we'll do it. Section 10.1, number 5, can we do that or do a problem like it? And, we'll knock it out.
Okay, thanks for letting me know that.
Yeah, for sure, most definitely. All right, anything else? Anybody else? I know there was a lot, like your classmate said, there was a lot of formulas, a lot of processes. But
Yeah, Mr. Tucker, I'm confused on what you did with the purple formula right here. Where did that come from?
okay, that came back from, that had been like section, let me see if I can pull it up.
That was in the factoring section though, right?
That was in the factory section.
Okay.
That should have been section 13.5 when that formula first showed up.
Okay.
Yeah. So that's a good question. So this stuff is leaning on your factoring skills from last chapter. So the way we handle this thing is that we don't have the opportunity to not do anything all the time. So we have to keep moving because we have content to cover. I'd rather that the next time we talk about it is a second time versus it being the first time. You know what I mean? Because now we're reviewing versus me waiting and stuff like that. So like I said to your classmate, if you have a question or if you come across a problem that you cannot do no matter what section or chapter it's on, make sure you bring them to class or come to the office hours. Those office hours are set there, sent that link. Those are different links then our class links. So, you know, you come to those office hours, those should be in on your course, your campus announcements. Have a link to call office hours so there's a different link for Monday and Wednesday, then there's a separate one for Friday. So, yep, check those times. And if you can't make either one of those times, shoot me the email so we can see what time you're available, so we can see if it matches up with my schedule outside of that. So, yep, all different type of options as far as you guys getting help on these problems. But you know, it's all about communication. Let me know what you need, and we'll go from there. Anything else before we close out today? That was it for section 14.2. All right. So if you guys are good, I'm good. We did just 2 sections. Yes, sir. Somebody unmute.
Yeah, I'm gonna go back and watch this video again.
Okay. Okay, cool. I got you.
I appreciate you sending those videos out though, for real. Thank you.
Yeah, no problem. I'm glad they help. I'm glad they help for sure. All right. Anybody else before we close? And what I can do is I try to, if this convert in enough time, I'll try to shoot this out to you guys today. So if you guys are good, I'm good. See you next class. Be safe, and I'll bring those questions if you have them. Y'all take care.
I had a question before you close.
Yes.
I reviewed my test, but there's still a few things that I'm struggling on.
Okay.
So what will I have to come to a remediation class or?
It's up to you how you want to do it. How many problems do you have?
It's just the slope and domain and range.
Okay. Let me see. What numbers were you talking about? What assignment? You said the actual test itself?
Yeah.
Okay, hold on a second. Let me see if I can pull it up. And that was test 10. What number are you looking at?
17.
You said number 17? Is that it right there?
No,
Okay.
it's asking me to find the domain and range of the function graph to the right.
Let me know when you see it. I'm just going backwards. Is it this one?
Yes, the graph is a little different though.
Okay. Now let me ask you, is it a straight line like this though?
Yeah,
Okay. So if you're talking about domain, you're talking about your X values. What values can you plug in for X? So that should just be negative infinity to an infinity. You can plug in anything for X. All right. And then as far as Y, it should be the same thing for this one. If it's just a straight line, you should be negative infinity to positive infinity for the domain and range.
find a point that was.
Oh, I had this up here. Hold up. Yeah. So yeah, so for that one, that's all it was. If all you have was a straight line like this one, negative infinity, infinity, negative infinity, infinity for both of them. That means you can plug in anything and get out anything, as far as the answer is concerned. All right, so now let me know. I know this one's asked for the slope of this line. Is that it? Or
Yeah, I can go to that one. I think that was another one I missed.
okay, but this one, vertical lines. If you go back to the notes, horizontal lines, the slope is 0, but vertical lines, the slope is undefined. Yeah, so that didn't call for any calculation at all. Just remember that vertical lines have an undefined slope. You know what the other ones are? Or
Yeah, but other ones I kind of see why I got wrong because I didn't fully read the question.
okay.
That was in the mistake on my end.
Got you.
Yeah, that's all I have for you.
Okay, cool, cool. So if you come across anything else, just let me know. And we'll knock it out, man. Make sure you're straight going into the next test. All right, man. You have a good one. All right, you guys take care. See you next class.
Have a good day.
Thanks, do the same.